Chiplet design is not something to be taken lightly. It involves quite a bit of technology just to get things designed and started.
It does.
And Siemens is very big into this area. So, can you tell us a little bit about what Siemens covers with respect to chip design?
Sure. So from a Siemens perspective, we have a full front-to-back solution for chiplet design, heterogeneous integration. That's encompassing 2.5D technologies, 3D technologies, 3D IC technologies. What you see illustrated in the background here is it all starts in a heterogeneous integration planning environment, or in our terminology, a cockpit. Very early on, we have to figure out how do we want to partition the design, what interfaces go in what devices, how those devices get oriented adjacent to other devices, from a placement perspective, from a stacking perspective. So all of that needs to be figured out early on, because that's where it's going to be the most impactful to engineering design decisions. If I have to understand if I'm going to have a thermal issue, I want to know that earlier than later, so I can take corrective action. So that's really the notion behind doing this early planning in this integration cockpit. Once we have a floor plan defined, the idea is we have a qualified design at that point that we can then take into the rest of the flow. That might entail the physical implementation of the interposer substrate, of the packaging substrate. Along with that then are all the various analysis pieces of it, electrical, thermal, mechanical, some of the co-analysis aspects. One of the big concerns with chiplet technology or heterogeneous integration is chip package or die-to-die interactions. Again, going back to that thermal example, I want to understand, am I going to have die that are impacting neighboring die from a thermal issue? Let me have an environment where I can simulate that. Beyond that, then we get into the verification steps to verify that design meets my process rules from a substrate perspective, and then also be able to do a 3D assembly verification to verify that everything is stacked and oriented correctly and then connected correctly through the substrate. The last piece, a little bit outside my area of expertise, but is the test aspect. That's one of the bigger challenges right now with heterogeneous packaging, is how do you test these devices? So we have a full solution for 2.5D, 3D testing.
One of the other areas is life cycle management, because these are very complex solutions that you have, and you have to track everything from where your content's coming from, as well as what kinds of versions you have.
That's a great question. And that's one of the things, historically I haven't been involved with up until the last year or two, where it's never really been part of the conversation, at least from a packaging perspective, right? And what we're seeing now is greater emphasis on data management, not just in the localized design perspective, but also in the enterprise level, is how do I take this package, release it to manufacturer, do all of that tracking. But between that level and the design level, we have to do work in process data management. So we have a product that complements our Teamcenter PLM tool, a product called EDA, Engineering Data Management. And what this allows us to do is to manage the work in progress, right? This is the revision control, check-in, check-out data, kind of giving you the historical data. So it gives you the lineage of the data, the traceability of the data. And as we engage in more, we'll just say chips-related, chips-funded programs, data traceability, trusted assurance are all part and parcel to that.
Great. Well, thank you for filling us in on all the things that Siemens is doing with respect to EDA, chips, and chiplets.
Good.